What's happening, guys? Scott from A Hornet's Nest. Welcome back to episode 19 of Tutorial Tuesday. It is so good to see you again. It's been a long time. Look, I know in episode 18 I said I'd do one monthly videos. Please forgive me. I know that I said that and it's not going to happen again. But hey, we got busy. But right on the precipice of you forgetting about me, I returned like a phoenix. So let's get into it. What are we building today? Well, let's take a little trip down memory lane back to season 2, episode 1 and 2, where we built the F-5 Armament Panel. I showed you how to design it in CAD, showed you how to build it, paint it, and I showed you how to do a DIY wiring job on it so we could just get it working. And it's been working ever since. I absolutely love this module, but I have wanted to make a couple of adjustments on it ever since building it. And the first one is let's go and upgrade its avionics. And by that, I mean, let's pull the latch open here. I'll show you what it looks like inside, and then I'm going to show you what we're going to replace it with. And I'm going to teach you how to make that as well. So let's get ourselves a little screwdriver, finishing taking off the latch off, and then we'll get into it. Alrighty, so that is unscrewed. Let's take our little hatch off, and you can see that the way I've designed it is we've got an Arduino in the middle and we've got a DIY circuit board on the top, and it's just a prototype breadboard and they work just fine. So don't think that if you're not following this tutorial that you can't make the one from episode 1 and 2. And as a little gift to you guys for coming back, starting off season 3, these files for the circuit board we make today, as well as the F5, are all going to be free back on Cults 3D for about a week, just to say, anyone that's been here, all 3,000 subscribers of you, hey, go have this for free. It has been an absolute pleasure making these for you. So let's get into it. So what we've got here is all the ground connections are connecting to the green board, all the signal wires are connecting into the Arduino, and you're probably thinking to yourself, Scott, I think you've got that the wrong way around. You're using red wires for the ground and you're using black wires for the signal. No, it's got method to my madness. I'm going to make a second iteration to the circuit board, and it's actually going to be using pull up resistors and pull down resistors, and that is actually eventually going to connect to a 5 volts. But don't get clogged down on that. Just trust that there is method to my madness, but the color of the wire does not matter. So we can see here, let me grab a trusty pen. We've got all of our ground wires connecting to here. And under all this wiring, there is a capacitor and a resistor that we used for the analog multi-position switch. And then we've got our Arduino. But I'm going to show you this. This is one I prepared earlier. I'm going to show you how to create a little breakout board like this that will carry the Arduino Micro. Why would I possibly want to go to all this effort if we've got a perfect solution here? Well, one, it looks cooler. And two, if I'm going to the effort of knowing how to wire up a prototype circuit board, I may as well go to that same effort on my computer, get it printed, get 5 of it, because you have to buy a minimum of 5 for most of your PCB houses. So now we're doing 1 set of work for 5 results. And now you've got 5 joystick controllers that you can make. So let me show you how we can create one of these real simple, and then I'll show you how to send it off. I'm going to use our good friends at PCBWay. They've just had their 10-year anniversary special. So if you've been following along before, you would have seen that on their website. I hope you got some good discounts and some good coupons. Now, let's get into Fusion and let's get into it. Alrighty, so here we are loaded up in Fusion. Let's see if we can design this in less than 10 minutes. And you don't have to have watched any of the videos before. I'm going to reteach it to you all so we have a fresh understanding for season 3. So we want to open up our fresh Fusion document here. We want to go to the page icon in the top left. We want to go File, New Electronic Design. And you're going to come to this page with your 4 icons here. Now this may be different if you're running the hobbyist version. I'm running the pro version here. So if you don't see any of the features, that is the reason why. But I'm running it because I get to make videos for you and I want to show you its full functionality to show you that it is actually worth the money. Now, what is an electronic design? Well, an electronic design holds a schematic, which is a map of inputs and outputs. It holds the 2D board shape of where we're designing the board, and then it also holds the 3D model or the render, so we can go take that and put that into another 3D file. Well, let's go and just place all our components in a schematic first, and then we can start organizing it in where inputs and outputs go. To do that, we want to click the very left-hand button here, New Schematic. There we go, and it's going to open up to generally a library manager on the left, a white area as your big work area, and then you've got your toolbar ribbon at the top. Now what we want to go do is start placing components. Pretend we're just drawing an ideas map of what we want, and it's going to show connections. This is not a topographical map. This is just a way to create order within the schematic to show inputs, processes, and outputs. Now, well, why don't we start building it from the middle and we'll go outwards. So we want our middle, so if we look here, to be this shield area where we're going to place our Arduino. Now I've gone and created a shield just because I make these a lot. You can go and make your own custom library, but you can also just use normal header pins and space them out 600 mil. And that's not 600 millimeters, it's just MIL. I think it's 601,000th of an inch. And to do that, I'm gonna go here to filter, and I'm just gonna search Arduino. I've created one here from the AHN custom library, and I'm actually gonna have a chat with the Fusion support team and see if I can create an online library that you guys can go download, and every time I create a new device, it's gonna update on yours as well. But hold that there, we'll see if we can do it. Double click, and then it just stays anchored to your mouse. And I'm gonna drop it, and you're gonna see another option or another copy of it stays anchored to my mouse. That's just in case if you wanna go and add multiple of it. If you don't, you just press escape. So we've got our Arduino there. Well, let's go and create a shield. A shield is where we can pop the Arduino into its plugs, and then we've got all these pinouts on the edges where we can go put multiple pins, inputs, outputs, all that good stuff. And you can see I'm running double rows, and the reason for that is the outer rows are ground, the inner rows are the ones connecting to Arduino. Because if you've ever worked with Arduino before, they generally only give you 2 ground pins. Now we've got about 20 inputs, and each of those inputs needs a ground to connect to, and that's what this PCB up here was doing for us. It was just creating that common ground rail. Well, let's just make it simple. Let's just connect all of those outer pins to ground, and that way we know every single pin has a ground with it, and you'll never run out of space. So it's about 17 pins in length, and it's 2 pins across. To find those, you want to search pin header. We can search pin head. It's the pin head library. If you are searching this and it is not showing up, it is because you do not have the library active. The top right of the Place Components panel, you'll see Open Library Manager. Go and search for the pin head library by just searching pin. You'll go here, and then you'll just turn its little switch on. It will indicate blue, and now that library is ready for use. So any library I'm referencing that you don't have, minus my custom one, that's how you're gonna go turn it on. All right, we wanna go and find a 17 by 2 or 2 by 17. Let's go here, there it is. And you wanna select the variant. This variant is a /90, which is, if we look down here, shows that it has a 90-degree bend to them. They actually are quite good, and I saw the first 90-degree pin heads that I've used in the Open Hornet design. It was on, I'm pretty sure, the AMPCD panel, which we're going to be looking at next episode. Very cool. But if you don't want to use the 90-degree ones, you just click the little drop down and you just select the verticals. Give it a double click, and now you can see that it sits on my mouse. Well, let's drop one on this side and one on this side, just so it's easy to look at. Now, I know it's looking topographical at the moment, but it's not. It is just so it's easy. Well, what else do we have here? We've got our double road here, And on these ones, I'm running 5 and 3.3 volts. And the reason for that is you never know when you need some 5 volt and you never know when you need some 3.3 volt. So pin out a couple, that way you're never going to find yourself stuck. The big thing with designing circuit boards is give yourself a bit of redundancy unless it's a very specific circuit board. We're creating something generic here. You don't have to use it with the F-5, you can use it with anything. So let's give ourselves some redundancy. So whilst we're in the pin head section, let's go and find ourselves a 2x5 and a 2x3. Great, so we've got all of our pins in, and now we can start pinning it out. And I want to give you a term, I don't know what it's actually called, but I like to refer to it as hardwiring it or soft wiring it. Hardwiring on a schematic is where I go up to the top ribbon, I select net, which is going to create the wire trace between components, and I go and connect them. If you're doing this, it looks fairly neat. But when you start going into more complex circuits, things are going to start crossing over. It is going to look like a rat's nest. So it's going to where I want to use a term called soft wiring, where we create labels and abbreviated nets. But I'm going to show you that very soon. But what I want to do is just create some soft wiring. Because all we're doing is connecting the Arduino pins to its respective neighboring pin header so we can pin it out. Now you'll see I have ignored the ground pin, and I'll show you why I did that very soon. Now we can go and connect these all to ground. Now, how would we go do that? Well, you want to tell the schematic that whatever's connected to this green line is connected to ground, and you would use a ground symbol. Now you're not going to search symbol, you're actually going to search supply. All libraries, supply, and you should get the supply 1 or 2 libraries. Now look, there is probably a design element with the correct symbol for the correct type of ground, whether it be a digital ground, analog ground, who knows what ground. But I like using the upside down T. Now, if you want to go use the correct symbol because you're more of an electronic engineer than I am, go for it. But all we're showing is that this line and anything connecting to it is connected to a ground. I am building these circuit boards. I'm not sending this out to somebody else to design the board. So I'm in control of everything here. We're going to pop a ground symbol down here, and we're going to pop a ground symbol down here. I want all of these edges, the outer pins, to connect to ground. Now, how am I going to do that? I'm going to click the first one, I'm going to bring it out, and I'm going to bring it down, and it connects to ground. Now, all we have to do is, let's zoom in a little. I'm just going to connect each pin and tie it to the ground. That dot shows there is a junction. It is showing that it is connected. If I take number 12, for instance, and I just go across it, you can see it crosses it without the dot, showing it is bypassing it. We want it to connect with a dot. So let's press escape, select and delete. And we're going to reselect net, and we're going to keep pinning it out. And we're going to do this for the opposite side. Now, for those there that are screaming at the screen saying, Scott, you could have just come down here and drawn a line down all of them and all of them would have connected real simple. Yes, you can. That is a real easy way to do it. But hey, I want it to look nice. Look, we're busy building circuit boards here. It's also meant to be fun. Very cool. And then I want to go and connect the grounds to the Arduino's ground, because every ground needs to be connected. So all I'm going to do is connect ground to pin 28, which is where it would respectively be. And then I'm going to connect pin 28 to pin 27, and it's going to ask, do you want to merge the segment N31 or net number 31 into the supply net of ground? Yes. Net 31 is the name of that little line that we just drew. It is the 31st net that doesn't have a name to it. We're gonna connect them. And then we're gonna do the same with this ground. Yes. Look at that, things are looking up. Now we can go do this with these connectors, because what we want here is I want a 5 volt, but I also want a ground sitting next to it, because that way if we want some LED lighting, or we're putting some more analog potentiometers in, or we're running more multi-position switches, every pin has an associated ground with it. That way you don't get this imbalance between it. Now you're asking yourself, why did I choose 5 and 3 pins? Because even though I've got labels here, 5 pins for 5 volts, 3 pins for 3 volts. That is as simple as my brain works. Let's go find ourselves a 5 volt pin, or a 5 volt symbol. 5 volt/1, it is just one option of them. It looks like a little lollipop. So let's go and select 5 volts. And we'll pop a lollipop up there, press escape, and let's go find 3 volts, 3v3, and it just has a different symbol. Cool. Again, probably not the most correct symbol to use, but we are the masters of our schematic. Alrighty, that is looking very cool. Now, you're probably asking yourself, do you have any idea of how these are going to be pinned out? Everything is pinned out as per the document in the F-5 Armament Panel file that you'll receive. Let's see if I can load it up just to give you a bit of a tutorial on that, and then it'll make a bit more sense. This is what it would look like. You'd get your AHN F-5 Armament Panel, you'd have your bill of materials, and you'd have an electrical diagram. If we open that PDF up, pop it on the screen, you can see that's the pinout, and these are all the switches. When I talk about interval switch 3, I'm talking about the switch. Pin 3 is this signal pin 3 here on the switch. So if we zoom in a bit, you can see we've got the registration key that stops it from spinning, and it is pin 3 is the one opposite to that. Pin 1 is on the registration key. So whenever we talk about it, that's what I mean. And the nice thing about these pins is if you get them the wrong way, all you have to do is switch them. They are not polarized in place through locking mechanisms. And then we went, and you may want to go back just for this to have a look how I created this resistor band to essentially use voltage dividing theory to create 8 different positions, or you can just go and download the Gerber files for my breakout board that goes on those, and you can see those in previous episodes as well. And I'll show you how to integrate all of that in this board. So that's the diagram. And then you go down the next page, and this is that schematic of what that prototype board looked like with the capacitor and the resistor. To give you a bit of reference of why that is there, this connector, which is around here in the fray, it brings in the signal pin from your 8-position switch. It runs it past a capacitor just using a 2.2 microfarad capacitor, and that's just going to filter some of that noise. It's going to create a bit of clarity to the signal coming through, and it's just going to give it a bit of stability. The smaller the capacitor you use, the more responsive it's going to be, because it's not charging up and discharging. The larger the capacitor, the slower the response time. So I found 2.2 UF or 2.2 microfarad is quite a good value. And then we put it through a 100 ohm current limiting resistor, just because I don't want any potential voltage spike to run through into that Arduino, otherwise you will fry your board. We're gonna need to still add this, but there's 2 options we can do. We can either go add it through the breakout board, which is super neat, lovely to do, or if you have already got through the tutorials and you have done it with the ring of resistors around, like what is in here, you can create this on your board using 2 very easy to find components from any electrical store. And I'll show you how to do that. So remembering the schematic, we're gonna add it to our new schematic now. Now, if we have a look at where this actually fits into the sequence, we are looking for the store selector COM via the breakout board, and that is connected to pin A5. Well, let's go and add that to A5, and this is going to bring me to soft wiring. It is where we can't add that nice schematic into this little gap here because it's just not going to look neat. So let's soft wire it. Let's zoom on in, and we're going to find pin A5 here, which is this one. It connects pin A5 to pin 18 of this jumper. If we go delete and we draw just a short line to here and press escape, draw a short line from here and press escape, we have created two nets. Now, what we've learned from the ground is if they are named correctly, anything with that name will tie into that. You've got to trust the process. So let's go and click label. We're going to click our first pin here and we're going to drop a label on it. And that's called N25. Another label, N31. We can go here, rename, click name, and we're going to call this store A. We're going to call this one store B. The reason I'm calling them store A and store B is if I connected them or called them both store A, they would just connect and we wouldn't have that flowing from the signal through the capacitors and resistors into the Arduino. Okay, so that's soft wiring. Let's now show you how soft wiring actually works. We now want to go and create this part here coming out of the common pin. So we create a line coming out of the common pin and we want to go pop a capacitor on it. Looking at our diagram in the top corner here, that's the diagram we're replicating. We want to go put a capacitor. Now I'm going to use a polarizing capacitor, and I found if you search in the SparkFun capacitor file, the 10UF polarized, the value doesn't really matter because we can change that. It's just the shape I want to use. And I want to use, I think it's called a radial 2.5 mil. It's a barrel capacitor and it's 2.5 mil pin spacing. And you can see we've got it right here. Bit different to what I usually use. Usually we use surface mounted components, and I would if I could, but I want to show you how easy this is to do, doing it with just whatever you've got in your electronics kit at home. I don't want you to feel that you need to go buy expensive equipment just to get this done. I'm going to go with this one. You can see a 3D models there trying to load for it. Let's go and pop it in place. Press escape. We're going to right click. We're going to go value. It's going to come up with a warning saying this doesn't have a defined value. Do you want to change it anyway? Yes, we do. And we just want to make it 2.2 UF. Great. And then we're going to draw a little line down and we're going to connect that little line to ground. Yes. So we're going to come out of store A, so we can even name that now. Let's go name or label, click it, store A. It shows you ones that you've already used before, but if you get the spelling wrong, you will not have them connected. It is terrible. Click yes, and let's just go and pop its name down. I'm actually just going to select everything, drag it a bit more, really make it look nice. Don't clutter yourself. You've got space. Excellent. So we're going to go from a capacitor, then we go into a resistor. So we're going to search resistor. R or RUS, they're kind of the same. The RUS ones, you kind of will find your imperial sized ones, but all we're looking for are these axial ones, which are your stock standard blue or brown resistors that you get in a little electronics kit. You don't have to go far to find these, and you can use a little larger if you've got it. If you've got a 200 ohm resistor or a 330 ohm, it's not a problem, but 100 ohm is probably the smallest you want to go. Now these are axial resistors because they run along an axis, and I've got them here at the 7.2 mil. If you don't want to bend them so tight and you want to give yourself a bit of space because you're not sure what size you're going to get, maybe choose the 11 mil, but I'm going to use 7.2 because I know that's what I've got at home. And we're just going to pop it there. Remember, while we're thinking about it, right click on the resistor, go to value, and we're going to type in 100 for 100 ohm. And then we're going to draw a net. And we're going to name this one Store B. Lovely. Connect it, yes. So you can see if we look here, pin 18 goes through Store A. We're running through Store A where we pass through the filtering capacitor. We're running through the resistor and we go into Store B. It falls all the way up here and magically connects and it goes to Store B into pin A5. There we go, as simple as that. All we got to now do is jump back up to the top of our schematic and we just need to go and name the 3 volt and the 5 volt net, because the reason is that 5 and that 3 volt is just a label. It's not actually telling the sketch anything. So we're gonna go name. We're gonna click the net we wanna rename, and then we're gonna go type in plus 3v3. It's an active name already. Press OK. And then we wanna go add a label. And the same with 5 volts. Plus 5v. Plus 5v. Alrighty, connect. And we want to connect. Look at that. That is all done. We are all ready to start building the board. Now, if you're still watching, a little gift to you, the top 3 people, the first to comment your country you're from, when you started watching the channel, it could even be today, or it could be from episode 1, it doesn't matter, and what module you'd like to use this with, I will post out 2 of these circuit boards to you for free as a little giveaway to say thanks for being part of a Hornet's Nest. So hit those comments. Don't miss out. Now, we want to go and build this board. Well, we've done the schematic, now let's design it, and we're going to design it to look very similar to this. Now, before we do that, I have missed out one piece. You can see down here, there is an individual little jumper connector that makes it a 3 across. And I'm only going to put that on one of them for the F5, and I'm going to show you how to do that. We want to search pinhead again, it's part of our pinhead library. We want to find a 1x1 connector and we're just going to drop it into the schematic. I'm going to take the 5 volts, I'm going to copy it, place it up here, and I'm going to connect it. And the reason for this is I just want an easy connector to show you that it is possible to run 3 rails to have your analog inputs having a bit of a nicer connection. There we go, that is all done. Let's go and switch to the document. It's going to load up in our 2D workspace. We've got the dark gray background just based off the environment settings that you're using. The black with the outline of yellow is your circuit board, and then Fusion will dump all of your components just to the left of it. All of our tools are at the top, and then we have this multifunction display panel on our left-hand side, and that will change just depending what tool you're using. Well, we want to go and dimension our board. Now it's a bit complicated in Fusion, but I'm going to show you how to understand it so you never have to feel confused about it again. Fusion does not use dimensions. Well, it does in the modeling world, but not in the electronic world. It uses coordinates. We've got a grid reference here where that little crosshair is, and that's 0, and 0. Just picture a big grid going either side of the integers. Well, we want our board to be 60 millimeters wide by 40 millimeters tall. Now, to change the measurement units, we're going to have to go up to the top left here to grid settings, and we just want to change the size of our grid to millimeters. Don't change the value, because that is important to ensure everything snaps correctly. It's a really good value, 50 mil. We're going to change it to millimeters, which equates to 1.27 millimeters. And we're going to press OK. We're going to select the top line of our board. We're going to right click and we're going to go properties. This says here the line extends from 160 millimeters on the right, so it's to the right of the x-axis's origin, to 0 millimeters. Well, we want our board to be 60 millimeters long. If we press apply, you can see it only affects that line. The x-axis is on the left-hand columns and the y-axis is on the right-hand columns. And we want the y-axis value of this line to be 40 millimeters on both. So that's saying it's going to be 40 millimeters from the origin. And we're going to press apply. We're going to right-click our slanted line, because that's the only one we want to edit. We're going to go properties, move this out the way, showing that it's stretching from 160 to 60, 0 to 40. Well, that length on the y-axis is correct. We just need to change this value. And we're going to change it to stretch from 60 to 60. 60 up here and 60 down here from the origin. Press OK. Now we get to just design the board. So let's get into it. What I also might recommend is go back to your grid settings, change it back to mils now that you're working just with the components. That way when you're selecting tray sizes, it's all going to be the same as me. We're going to select our component, left clicking and holding drags it around, right click rotates. And we're going to place it roughly in the middle. Lovely. And we're going to go place our jumpers as well. Now having a look here, I've got all the grounds on the outside, so why don't we go and rotate these and put the grounds on the outside as well. That way you know any pin on the exterior part of the board is a ground pin. There we go. And let's delete their names, just because I don't need to know that they're called jumper 3. I'm building this board, so I know how to build it. If you're sending this to someone else, maybe. Delete. And delete, and I'm going to delete the $U one as well. Beautiful. Let's go and place our capacitor and resistor in the middle, and the reason I'm popping them in the middle really close to the store B pin is because you want the capacitor to be as close to the entry point of the Arduino as possible. There we go. And then going to move its value just into it. You don't have to have the value showing, but I like to have them, so I'm going to send these out to a couple of people, and I want them to make sure that they have the correct ones. And we want to go place this jumper pin next to where it belongs. So it's going to go ground, store A, which is coming from the multi-position switch, and we want a 5-volt next to it. And you can see if we had changed those snapping measurements, it wouldn't snap so nicely, and we know it's snapping at the correct intervals. Well, that is as quick as it is to place everything. Let's go and actually wire it up, and you've got a couple of options. Up at the top ribbon panel here, you've got route manual, which allows you to select a point. We're working on the top layer. You can select the bottom layer if you want to do it on the bottom copper, but we're going to do it on the top. I like to keep the bottom for a big ground plane, and we're just going to change the trace to 12 mil. If you've got space, make it 12. Give yourself some good thickness there. If you need smaller, 6 is also okay. And we're going to select one pin, and we're going to drag it down to the bottom. Now that's pretty tedious, especially if you're doing really quick straight lines like this. The other option is you can go to quick route air wire, and you can select the air wires, and that is a lot quicker. Now I'm not going to go quick route air wire this because I want to do a custom job on that. Beautiful. I'm going to choose route manual. I'm going to select one at the top here. I'm just going to drag it all the way to the bottom, and it's going to connect all of those. And we're going to do the same for 3v3. Wonderful. Well, let us go and connect 5 volts to 5 volts here. And then I might actually have that coming out of the pin like that. And we are ready to connect store A. We're going to come out of store A. We're still working on the top, and you can see it will try force objects out of the way if it's going to collide with them. If we want a bit of a refined snap and we don't want to use the full 1.27 or the 50 mil, if you press Alt, it gives you less of an increment. Press and hold Alt gives you to the capacitor. Great. And then all we've got to do now is just connect our 3 volts to their buses, and then we are pretty much done. Now you see how I want to go the shortest way possible, right? Now I could go all the way up here, which is an option, but I want to show you another way of doing it, just so you have all the tools in the toolkit if you need them. If you want to go underneath, if you want to bury down into the bottom copper layer because you find that's easier, you drag it out to where you want to start. You want to create what's called a via. It's like a secret rat's tunnel that buries down into the next copper layer. And to get one of those, click the middle mouse button, it creates a small little hole, click it with the left mouse button, and now it starts drawing blue. And that is showing that it's drawing it on the bottom layer. We want to come back to the top. We're going to middle mouse button again, left click to place it, and then we are good to go. And that looks just fine. And we're going to connect our 5 volt to 5 volts there. All we got to do now is create a ground plane, and a ground plane just floods the bottom with copper and you can tap into it with all the grounds. I really, really like how it's used. To do that, we're going to select the bottom layer because we want to draw it on the bottom layer of the board. We're going to select polygon and we're going to enter the signal name, G and D. It knows that anything with G and D connected to it will tap into this polygon. It is a really easy way of creating this. And we are just going to draw this polygon around our board. There we go. And even though it's drawn outside the board, it will only fill inside the board's dimensions of where it can. And if you zoom in, you can see all of our ground pins, once they get soldered, will tap into that big copper plane. All we have to do now is add a little bit of text to give you some idea of where we're going to place things. So we're going to press done. We're also going to press top layer, just so we can see the red tracing. We're going to go document. We're going to go draw text, or you can press T for the text hotkey. The text we want to enter is going to need to be placed on silk screen top or silk screen bottom, just depending on what side of the board you want it to be placed on. The silk screen is just a graphical layer on top of the circuit board giving you bits of information. Silk screen top, and we want to call this Arduino Shift Enter Micro. And we're going to place that there. We might want to draw a couple of lines around the 5 and 3 volts, just so we know that there is voltage there and we're not going to just mistakenly pin into it without thinking about it. We're going to select short dashed lines. I'm using a hard corner here. You can use 45 degrees, we can use a hard 90 degree. There we go. Escape, draw around this one. Beautiful. And now we can just go draw how we want. You can see I've gone and popped a Hornet's Nest logo on there. I've called them 5 and 3 volts, and we're pretty much done. And I've just popped a little version number on the top. So that way you can see whenever you download these files, which version you're up to, because if I make changes to these, you're going to get them for free as well. And then on the bottom, just because that this is a custom board that could go to anyone, I've added a couple little extra features, but this here is all you need to know for your own boards if you're designing them. Well, that is essentially us done. Go and text it how you want. Go make as many changes to it as you want. And then when you're ready, come back here and we're going to go and export it to send it to our friends at PCBWay. To do that, we're going to click Manufacturing, and we're going to click the second option here out of these 4 symbols called CAM Processor. It says your PCB design has changed, CAM output using the last saved version. There we go. Let's save it first. You'll see on the left-hand side, it's going to be called PCB. It's going to come into our schematic here. It's going to update everything. And now we can go CAM Processor. On the top here where the little file import icon is, we're going to go templates, and we're just going to do a 2-layer default circuit board. Now this is going to be fine for companies such as PCBWay, JLC PCB, use whichever one you want, but the friends at PCBWay, they do an excellent job in giving me wonderful circuit boards. I'm going to come down to Gerber, and we're just going to have a look at the top copper. This is a bit of an idiot check. Is this what we're looking for? Is this what we're expecting? Bottom copper, you can see all that black is that ground plane, and you can see it tapping into it. Profile, solder masks, pastes if you're using SMD components, and we've got the silk screen. And you can see we've got the silk screen top, which is where we added that text, and we've got names top. Now I'm losing my values here. If you want to add another layer, you click the layer icon in this panel, you scroll down to the layer you want, and we want to use values top. We're going to press OK. And now you can see it's added those values in there. And then you can go and save that as your own custom preset. That way you don't have to keep doing that. We want to ensure that we've got export as zip selected, and then we're going to go process job. I'm going to call this AHN EP19 controller. And then we're going to go and save it. And that's pretty much done. All we got to do now is jump onto the website at PCBWay, and I'm going to show you how to upload it. So on their website here, we're going to go to Instant Quote, and we're going to click Quote Now. We're going to go to this section here, Quick Order PCB, and any website you're using, any company, they're all going to be pretty much the same process. Quick Order PCB, and I want to add a Gerber file. And then we're going to select our zip file and press open. It's going to upload it, it's going to give the board dimensions, and you can see because of how small our board is, we're within the 100mm by 100mm bracket, it's going to cost $5 for 5 PCBs. It is absolutely incredible the price that they do. We're going to select single piece, one different design, make sure you got the correct dimension in there, because if that's wrong, then you've exported it incorrectly. 2 layers, 1.6, and we're going to select black, and then the surface finish doesn't really matter. If you're happy to pay a little bit extra, go HASL lead free, otherwise it really isn't a problem. And for $1.50 extra, I'm going to remove the product number, just because that way your board is looking the way you want it. And all you got to do is press calculate, go send it off to them, get it in the post. You're going to get a beautiful circuit board that looks like this, and really it is quite lovely. And then you're just going to go install it. Pop your capacitors and resistors in. You've got female header pins here for the Arduino. They call it 1x17 female headers, male header pins here, and you are good to go. And then go watch episode 2 to see how to upload the code into the Arduino, and you are good to go. So yeah, absolute pleasure making videos for you again. It is so good to be back. So as always, go enjoy your week ahead, go enjoy your flight simming, stay safe, and I'll see you in the next episode. And those that know what to do to get the free circuit boards, hit the comments below. You know the 3 criteria. And I will see you next episode where we go back to the Hornet and I show you how to build the AMPCD, get the displays going, and how to use button boards. So enjoy your week, guys. I'll see you soon.